In today's class, we shall be studying the atomic structure of chemistry. Now, you are familiar with the idea of atoms. Last day when we were talking about matter, we studied about elements and compounds, and there it was said that matter is ultimately made up of the elements. And if you go on dividing that element even further, you reach the realm of the atoms. So up to this much we studied in matter. But in this chapter we will be dealing more about the subatomic particles. We will be studying in details about the nucleus, about the protons and neutrons inside the nucleus, and the electrons revolving around the nucleus. Also, we will be studying a little bit about how these subatomic particles were discovered, what are their charges and mass, and what are these terms like atomic number, mass number, and so on. Now, who was it who first gave the idea of atom? As per the Indian philosophy, it is believed that there was a certain sage by the name of Kannada who first gave the idea of the atom. He had coined the word Anu, which is a Hindi word for atom, and Paramanu, another Hindi word for the subatomic particles. Kannada believed that though the atom is the smallest indivisible particle that may or may not have an independent existence, but if you divide the atom even further, you will get something as Paramanu. What is that Paramanu? There is no idea about that from his texts. But there is another person by the name of Democritus. Democritus was a natural philosopher of ancient Greek. So Democritus also came up with this idea of the atoms. He actually coined the word atomos, from which the word atom as we know today has been derived. And what does atomos means? Well, in the Greek, the tomos means something that can be cut, and the letter A in front of that means not. So A is like, whenever you put A before any Greek word, it means the negative of that. So A before tomos means something that cannot be cut. So Democritus again believed that the atomos in the Greek language is something that cannot be cut any further, and from there the word as we know it today, atom, has been derived. So Democritus' idea was this, that if you take a slice of bread and if you start slicing the bread with a sharp knife, a very sharp knife, there will come a time when you will get the smallest slice, and that smallest slice will have a thickness which will be similar to the thickness of the edge of that sharp knife. So that thin slice, you cannot cut it any further with the knife. So using that reasoning, he said that in a similar manner, it is possible that if we have the sharpest tool and if we can keep on cutting matter, any matter, there will come a state when we will reach the level of the atomos, and then we cannot cut it any further, and thus he gave this name. He also provided an idea about the atomos. He said that well, an atomos, as we will study shortly, is mostly void with very little matter in it, and we shall study it that in general an atom is mainly empty. There is very small matter in it. And why did he give this reason? He said, well, if matter or if atom was not mostly empty, we would not be able to slice through the bread. The knife would have been obstructed by the atoms that make up the bread. So that is why he reasoned that any matter is generally more than 90% void. So that is the preliminary idea of how these concepts of atom and all came into being and how the names came into being. Now coming to the modern era, that is in the 18th and 19th century, there was a scientist by the name of John Dalton. And Dalton proposed an atomic theory, and these are the postulates of the atomic theory. So what are the postulates? Number one, he said that all elements are made up of tiny indivisible particles called atoms. So these are the keywords, tiny and indivisible. You cannot divide them any further. He said that atoms are not created or destroyed during chemical reactions. Whenever you make a substance undergo chemical reaction, atoms, they are neither created nor are they destroyed. In his third postulate, he said that atoms of an element are identical, but atoms of different elements are different. So that means if I take the element, say magnesium, all the atoms that make up magnesium are identical. You cannot distinguish between them in any manner. But atoms of magnesium will be different from chlorine or helium. There will be difference between atoms of these three different elements, but the atoms that make up helium or the atoms that make up magnesium will be same throughout. Number 4, he said that the atoms combined in fixed proportions or in whole number ratios in chemical reactions. So if you are trying to form the compound MgCl2, then no matter how many times you carry out this reaction or wherever on earth you carry out this reaction, one atom of magnesium will always combine with two atoms of chlorine. This fixed ratio of 1:2 will be maintained always in the chemical reaction. Similarly, if you take sodium chloride, one atom of sodium will combine with one atom of chlorine everywhere. Finally, the fifth postulate of Dalton was that in chemical reactions, atoms, they do not change, so they simply rearrange. So if you are carrying out a chemical reaction, suppose you are carrying out this chemical reaction of NaOH plus H2SO4 such that it gives you Na2SO4 plus H2. I have not balanced the reaction, so suppose you are carrying out this reaction. Now here, what he meant by this postulate is that sodium of atom here, the Na is combined with OH group, and here we see along with the OH group there is the hydrogen. Or you can take example for this compound that the atoms of hydrogen are combined with SO4 group, and on the right hand side of the equation the atoms of sodium are combined with the SO4 group. So Dalton said it is not that these atoms of H, the two atoms of hydrogen, have converted by some mechanism into two atoms of sodium. That has not happened. The atoms have simply rearranged themselves. The sodium atom, which was previously combined with the hydroxide group, has now went on to combine with the sulfate group, and the hydrogen atoms which were previously combined with the sulfate group has now went on to combine with the hydroxide group. So atoms do not change. Sodium atom does not become the atom of hydrogen, or magnesium atom does not become the atom of chlorine, but they rearrange themselves. That can happen as per Dalton's postulates. Now, how were these subatomic particles like electrons, protons, neutrons, how were they discovered? Well, for that first we need to know what is this. This is known as a cathode ray tube. At times it's also named as the discharge tube. This is called as a cathode ray tube or a discharge tube. So what's the construction of this? So first of all, there is this column, a cylindrical column, generally made up of glass. This one here is the cathode, and this one is the anode. And outside there is a source, a voltage source. The positive terminal of the voltage source is connected with the anode. The negative terminal of the voltage source is connected with the cathode. So negative terminal goes with cathode, positive terminal goes with anode. Now when this initially what happens in this glass tube, there are certain air molecules. That air is being pumped out using a vacuum pump. Once this region is almost near vacuum, you can take any gas as per your need of the experiments. It can be hydrogen gas, it can be helium gas, and that gas is inserted into this discharge tube. After that, this voltage source is switched on such that a high voltage or a potential difference is created between the cathode and the anode. When that high potential difference is created, it is found experimentally that this region of the discharge tube, it starts to glow. When a high potential difference is applied, this region starts to glow, the region opposite to the cathode. So from there it was inferred that there must be something. It can be rays, it can be particles which are traveling from the cathode towards the anode when the voltage source is switched on. These rays were named as cathode rays. The experiment was first performed by the scientist Crookes. It was later on repeated by the scientist Chadwick and Thomson. Thomson called these particles constituting the cathode rays as corpuscles, which was later named by another scientist, Fitzgerald. He was another scientist. He named the corpuscles as electrons, and that is how we know it. These negatively charged particles. So they were initially called cathode rays when Crookes performed the experiment. Later Thomson performed the experiment with a modification, and he named these particles constituting the cathode rays as corpuscles. And finally Fitzgerald named them the electrons. So what was the modification brought about by Thomson? Thomson made these cathode rays pass in between an electric field. So on this side he placed a positive electric plate, on this side he placed a negative electric plate such that there is an electric field. And it was found that these cathode rays, they were deflected towards the positive plate. They were attracted by the positive plate, or you can say they were repelled by the negative plate. This was what Thomson performed. And Crookes made these cathode rays pass in between the pole pieces of a magnet. Between the pole pieces of a magnet. And he found that when they were passed in between the pole pieces, they were again deflected by the magnetic field. So from that they came to this conclusion that whatever be the particle constituting the cathode rays, these particles are affected by an electric field and by a magnetic field. Later on, when they were named as the electrons, the properties of the electrons were clearly stated. So, what were the properties of the electrons? Number one, electron has got a negative charge of -1 unit. The unit is coulomb. So this is the charge of an electron. Minus sign signifies it has a negative charge and 1 unit charge. Number two, the electron is a negatively charged particle. And number three, the electron has a mass of 9.11 into 10 to the power minus 31 kilograms, which is 1 by 1840 times the mass of hydrogen atom. So these were the three properties of electrons that were deciphered by using the cathode ray experiments. But the scientists at that time knew that an atom is overall neutral. So if electrons are having the negative charge, then who is having the positive charge? This was the obvious question that was raised, and during that time the quest to find these positively charged particles started. So for that, a modified version of the experiment was performed. In this modified version, this is the anode connected with the positive terminal, and this is the cathode, but it is a perforated cathode. Perforated means that there are small holes made on the cathode. Now, as before, when a high voltage potential difference was applied between the cathode and the anode, there were some rays, the cathode rays, which were traveling from the cathode towards the anode. That was already discovered, but this time by using the perforated cathode, it was found that there is a glow on this side as well, which means there are some particles or some rays which are traveling from the anode towards the cathode. That is from the positive terminal to the negative terminal. These new kind of particles or rays that were traveling were called the canal rays. And it was stated that the particles constituting the canal rays are protons, which have +1 coulomb charge. Protons are positively charged particles, and that the protons have a mass of 1.67 into 10 to the power minus 27 kilograms. These were the properties of the protons. So now we had found the positively charged as well as the negatively charged particles with simple experiments performed using a discharge tube. These experiments, by the way, the first experiment, the one in which the electrons were discovered, was performed by Crookes and Thomson, and the second experiment in which the protons were discovered were performed by Goldstein. Now, there was something at that time after these electrons and protons were discovered known as the plum pudding model or the J.J. Thomson model of the atom. The plum pudding or the J.J. Thomson model of the atom. So what was this model? J.J. Thomson, the scientist, said that if this entire thing is an atom, then these small dots are the electrons which are negatively charged, and these electrons are moving in a sea of positively charged particles, which is this background. So this is the sea, and on this sea there is this electrons sitting like dots, just as if you have a pudding cake, and on that pudding the plums are these small points. On the puddings you can find certain plums randomly associated at various places. In a similar manner, if the entire atom is a pudding or is a sea of positively charged particles, then the electrons are the plums, or they are distributed in a scattered manner throughout that pudding. This was the J.J. Thomson model. But it was found out that the J.J. Thomson model has got certain flaws, because of which Goldstein performed further experiments in order to study the atomic model, and in that some other inferences came to light. So what did Goldstein perform? Well, Goldstein took a source of particles. This was a source of alpha particles. The alpha particles were emitted towards a gold foil. And surrounding the gold foil was a ZNS coated screen. So this was a source of particles. It constantly emitted or produced alpha particles. Alpha particles are basically helium nucleuses, 4 helium nucleuses from which the 2 electrons have been removed. And there was a gold foil towards which these particles were aimed, and behind the gold foil there was a screen which was coated from inside with zinc sulfide. Zinc sulfide is a material that produces fluorescence when any particle hits it. So in this experiment, whenever Goldstein performed the experiment, he found that there were a lot of particles which were causing the fluorescence in this region. There were a few particles causing the fluorescence along these 2 edges, and some of the particles they traveled exactly back. So what was the conclusion that Goldstein drew from this? Well, Goldstein said that if this is an atom, then that positive charge is somewhere inside. It is concentrated in a very small region. That is why when these alpha particles were traveling, most of them traveled undeviated. That is, they caused fluorescence behind the gold foil. Few of the alpha particles were deflected when they went on to hit the nucleus. But since the nucleus is a very small region in the atom, the probability of this deflection was less. That is why the fluorescence at the edges occurred very seldomly. It did not happen frequently. And in the rarest of the rare cases, it so happened that some of the alpha particle went on to collide head-on with the nucleus, a head-on collision. And in that cases, the alpha particles they returned back. They retraced their path. So from this, Goldstein came to the conclusion that an atom is mostly empty. In an atom, the positive charge, that is the nucleus, is concentrated in a very small region, and the electrons they are very far away from the nucleus. He also came to the conclusion that the nucleus is the seat of the positive charge because it was repelling away these alpha particles.